Everybody, Catie Harris from Philly Wellness Center. So, the secret language of stem cells. How do they know where to go, what to do? So, have you ever wondered why or how a stem cell knows where to go? Like you inject it, and how does it magically appear where it's supposed to be? Or how does it know what kind of tissue to become? I mean, it almost sounds mystical, right? But the body has its own GPS system for healing. But it's not magic, it's cellular communication, and it's one of the most intelligent processes in biology. So, excuse me, the SOS signal, how stem cells get called. When tissue is injured or under stress, it sends out what I call a biological SOS. So damaged cells release cytokines, chemokines, growth factors. Maybe you've heard these words before, but they're tiny signaling molecules that travel through your bloodstream. It's like throwing flares out in the night. And the stem cells sense those signals, they see those signals, and they're like, I got you covered. So they're covered in receptors. The stem cells are covered in receptors like antenna, and they're constantly scanning for distress frequencies. So when they detect one, they migrate towards that source of inflammation. That's called chemotaxis, literally moving towards a chemical signal. So yes, stem cells are mobile, intelligent responders, and they know where they're needed because the body tells them. And that's where, stuff like softwave comes in. So softwave is an acoustic sound wave therapy that we use on injured tissue. So when you stimulate those cells, it creates an inflammatory response and it actively recruits stem cells. It's almost putting out that flare, that SOS saying, hey, come pay attention over here. We need help. And that's how soft wave and different therapies like that work. Okay, so two, the the manual, how do they know what to become, right? So if a stem cell is undifferentiated, it just means it's a generalist, and it's just a cell. It's nothing at the moment. So what the stem cell does is it arrives at the site of injury and it starts reading the local environment, like, okay, what's needed here? It listens to the molecular conversations around it, to the growth factors, cytokines, hormones, even the electrical charge of the tissue. And based on those cues, it makes a decision. It says, I need to become a cartilage cell. I need to become a neuron. I need to release growth factors and wake up dormant cells. And that's what's called cellular differentiation. And it's all guided by environmental signals, not pre-programmed fate, right? So the cell's not destined to become something. It becomes what it needs to become. That's your body's local chemistry writing the instruction manual. So it's pretty amazing. And then the matrix connection, so how they anchor and build. But for all of this to happen, stem cells need a landing pad and a healthy extracellular matrix. That's that protein-rich scaffolding that holds your tissues together. So if the matrix is damaged from toxins, chronic inflammation, poor circulation, stem cells, they can't attach and they can't communicate. So that's one reason that therapies they combine stem cells with ozone, red light, peptides that helps to clear the matrix, restore oxygen, and make sure the communication lines are open. So there's lots of things that need to go on. It's not just one there. It's never just one thing that's doing all of the work. So when we inject stem cells or we receive umbilical derived cells, they don't just wander aimlessly. They follow chemical signals, anchor into healthy tissue, and activate repair through growth factors and exosomes. But remember, the healthier the terrain, the clearer those signals are going to be. And that's why preparation matters so much more than the procedure itself. So that's what we do. I've had some pretty sick patients through the years, and they've been interested in stem cells. And the first thing I do is prepare the terrain. We want to get the membrane health up to speed so that there's something for the stem cells to signal. Because if you just give a very sick person stem cells and the terrain is not enough, then it's going to fall flat, right? And stem cells work. They always work. It's just a matter of them having the resources to do the work. So in the next video, that's what we're going to talk about, what the stem cells need to work. They need nutrients, fats, mitochondrial energy that make regeneration possible, because no matter how advanced the therapy, if your cells don't have the raw materials to rebuild, they can't complete the job. And this is where real regenerative medicine begins, not just in the injection, but in the energy and the intelligence of the terrain that supports it. So be sure to subscribe to the Mitochondria Code to learn more and get the next video when it comes out.